initialization, okay? Meaning if I want to create an object, okay, how can I create an object and have certain values set up in the object? I mean, you could say, yes, I could use a constructor to which I pass all the information I want to pass. For instance, for a candlestick, we know that the candlestick has an open, high, low, close, volume, and a date. I may want to say when I construct my candlestick, I want to pass what the date is, the open, the high, the low, the close, the volume. I can put those as the arguments to my constructor. Well, that's not an initializer list. That's a constructor that takes a bunch of arguments, and you use those arguments to construct the object. Now, why did we say we might want an initializer? Did we talk about the fact that when you have a constructor, that all your member variables must already be initialized? Okay? And then what do you do after you initialize? Your constructor goes and overwrites these things possibly. For instance, in our candlestick class, we have a constructor that takes open, high, low, close, volume, and date. Well, when you finally enter the constructor, meaning you now are just about to execute the code of the constructor, well, all your member variables must exist. Otherwise, you would not be able to, in your constructor, say, set the date or set the open to 0, okay? You can do that if there is no open variable ready to take on values. So the variables must exist. But if you have a variable, it also has a value. So by the time you enter your constructor, all your variables exist and have been initialized with something. Okay? Now you might say, what's the something? We'll get to that in a second. But whatever those variables have been initialized to, you're now in your constructor doing something and say, now put these values in those variables. So you're overriding them. Okay, imagine that the constructor I'm talking about, takes the date, open, high, low, close, volume. Well, when I enter the constructor, the date, open, high, low, close, volume have values in them. Okay, as I said, we'll see what those values would be. And then you say, okay, like if you look at the date, you would see that the value is January 1st of year 1. Then what you would want to say, okay, well, I want to replace that by the date that you just passed me in the constructor, okay? What would be the original date that's inside your object? Does anybody know? Yes? Well, I'm not talking specifically about the date now. I'm talking about any member variable that you have. What would the value of that member variable be when you enter your constructor? Or what do you think it will be? Is that a sign? 0? What if I'm talking about a member variable that's a string? That's not going to be 0.
No.
Huh? That would be an empty string. So in general, what do you think is the value that is put in?
No.
That would be if you're talking about a reference. All right? Remember how we said objects get constructed. If I have an object that has to be constructed, is that I thought somebody was answering there. It was a stretch. Okay, so let's say that you have an object that has to be constructed. What must you first construct before you construct the object itself? Like for instance, form 1. Okay, when you do this thing, you have something called form 1. When you have to construct form 1, what has to already be constructed so that you can do the rest of form 1? Excuse me? No. Form 1 is derived from, what's the base class of form 1 that you get?
Class form.
Form. Okay, you know that form class that every other form is derived from? So that when you make an application in Windows Form, what Windows gives you, what it calls Form 1, is a class. It's the class Form 1. We usually say, hey, let's change the name so that it makes more sense, okay? Like in this, we may have a form user interface, okay? So that tells you, but that's a class. So whenever you have a class and you construct the class, well, the first thing that happens, you construct the base class, okay? Now, just saying that to you That rule, you can recursively think about it, because if I have a class like a form user interface, what must we first construct now? What's the class that has to first be constructed?
User, class user. If you have user.
No.
Mhm.
Again, I mean, I gave you the answer 2 seconds ago.
Oh, the form.
What is the base class of every single type of form?
Form.
Form. You start an application and it gives you a class called Form1. Okay, that's how it always starts. We can change the name, but let's say we have Form1. Now we're going to construct a Form1. Well, before you can go and finish up whatever there is to do in Form1, what must you already have set up? You just told me.
The form.
Form, because that's the base class. Before you can do anything with your class, you got to construct the base class. Okay? Well, before you construct the base class, what must you construct therefore? Let's try again. You have a class. I'm not going to use any names now. You have a class. You want to construct that class. What did we say you first have to construct?
Base class.
The base class. I'm constructing the base class. Ooh, what must I construct before that then? You just said it. The base of the base class. Oh, I got to construct the base of the base class. What must I construct first? The base of the base of the base class. And you say, does this go on forever? No, otherwise we'd never be doing any software, okay? No. So where do you think this thing would end?
Object.
At object, okay? Which is the base class ultimately of everything in the .NET framework. So in the .NET framework, you have the object class, and derived from object class, there's a bunch of things, okay? Maybe at some point here, there is a form class. And then, for you, there's a Form1 class. So when I'm going to construct this guy here, what happens is I have to construct the form. If the form, which is the base class, has its own base class, I have to construct it. If it has a base class, I have to construct it until I get to constructing the object. Okay? You can derive directly from object if you want. You know, you can have your own class, and when that own class has to be constructed, it has to construct its object class. Do we understand that part? And just by knowing that one rule, when I construct a class, I have to first construct the base class. Well, then you say, oh, so when I construct the base class, what did we just say have to do? You have to construct the base of that. Okay, well, when I construct the base of that, oh, I have to construct its base. And you say, where does this stop? It stops at the class, which is the ultimate base class, which is object. Okay, so now, if this form here has a bunch of variables in it, when it gets constructed, depending on what the constructor says, those member variables will be set to something. Maybe, for instance, if you're talking about a date time object, which has a date in it and a time in it. When you construct this by default, it will simply set the date to 111 and the time, I think, to midnight or something like that. Okay? That's what it will do. And therefore, when you ultimately get, after having gone and initialized, constructed each one of those, your code returns. You come back from returning from constructing this guy, finally to do your class, because at this point, the edifice, all of its ancestors and all the member variables have been set up to this mechanism of saying, hey, construct my base class. Once my base class is constructed, I know that all my member variables are set. I can now do something like overwrite what was put in those things. Okay? Well, can someone think of this as being a bit inefficient in that when I'm constructing something, I have to construct the base class. It's like, hey, I'm building a 3-story house. Well, that's great, and you're gonna live on the 3rd story. Well, the only way that's gonna happen is if the 2nd story already is built, and that won't happen until the 1st story is built, and the 1st story needs to have the slab done. Okay, so finally, when you can finally move into your third story so that you can bring in your appliances and everything, well, the floor is set and all of that, it's the same thing here. By the time you're ready to do the constructor here, all the member variables have been established. The problem is that they have been established by calling the previous constructor. It spent time setting up these variables only to have you come along and say, I want the date to be, March 6, 2025. And now you might say, what's the big deal? Well, the big deal is that some objects, sometimes to construct the object, it can be expensive, okay? Takes a lot of time, maybe it requires you getting some data across the internet and so forth. And you say to yourself, isn't there a more efficient way for me when I call the constructor or when I want to build such an object to tell it right off the bat, here's the value I want to have in this member variable. Don't go, create it to your constructor. I want you to initialize the values with these things, okay? That's what the initializer list is. And here, they give you a little bit of an example. And they show you, for instance, a class, okay, a bunch of geeks, like us maybe, class geeks, and you'll notice this class, does it even have a constructor? No, but this is C#, so under the covers, is there at least one constructor? Yeah, the default constructor. It doesn't show it to you, so when you don't provide a constructor, that's what happens. But nevertheless, you notice that this class has 3 members, okay? And they're all properties. They have author's name, author's ID, and how many articles you've written. So far, so good? Now, if you were to construct, if you were to write your constructor for this, how many parameters would you want to pass to your constructor?
3.
Yeah, you would want to say 3 because when you say I'm going to instantiate a geek, okay, I'm going to pass the name, the ID, and the number of articles, okay? But notice that when you finally do enter your constructor that's going to set these 3 things, those 3 things will already have values because the constructor of this, before you can even get to that, would call its base class constructor. You say, well, there's no base class. Well, there is object. Object is always there as the base class, okay? So those guys would have been set, and you don't want to set them in order to then, in the constructor, go ahead and overwrite. For instance, author's name would have been an empty string, the integer for the author ID would have been set to 0, and the number of articles would also have been set to 0. And then you would come along and put your own values. Well, if you want to put your own values right off the bat, okay, you can just do something like this. Notice right here, I am creating an object of type geeks, okay? And I am initializing all the members that I want. I don't have to put all of them. I can initialize only 1 or only 2 or all 3 of them, which is what we're doing here. And the syntax is just what you see here. I just wanted to make it bigger for you. Here's the syntax. You just simply say, I want a new geek. Now that's using any constructor that you would want, but anyway, this is the default constructor. And what you say is, and initialize the author name with that, the ID with this, and the number of articles to this number. Do not do the other stuff, okay? All right, so that was your quiz today. Let's move on and finish up what we have. If we're talking about project number 2, many of you said you've already gotten to the point where you have it display or being able to display multiple stocks. Let's check things out. This thing is doing a bunch of things to me. Let me make sure, oh, this is the wrong thing. We are in C# over here, so let me quickly do this. Project C#, and I'll know which one I should be looking at. Okay. project number 2. I'm waiting on this thing to do its magic.